You have to let me go.
No.
The ropes are too loose. I'm pulling you with me. You have to let me go, or we both die.
You go or...
So, we are still in the beginnings of talking about how to do categorical variables. I want to do one more brief overview type thing. We're going to look at two data sets super quick. There's details we haven't talked about, but I just want you to see what it looks like to work with categorical stuff. The first one we're going to try to work with predicts age based off how much you walk per day in miles and what ice cream flavor you like. I've decided to call it how old so that I avoid using age because that's one of my variables in the data set. Just making a plot of whether walking matters. It looks like the more you walk, the more we predict you must be young. And if I color these dots by ice cream, I'm going to make the dots a little bolder. Do I see a distinct pattern between the black dots and the red dots and the purple and green? Well, I don't know. That's hard to see if there really is a pattern. When I make my prediction model, I'm going to do age with walking and ice cream, and then I'm going to have walking times ice cream. And the reason for that is something that we will want to talk about later. And first thing I want to do is plot that fit to make sure that I like the way the residuals look. Okay, residuals are looking all right. Now let's try a summary. See what's really important here. It doesn't all fit on one side, so I'm going to size out my window a little bit. And what do I see? Does walking help predict your age? Tiny p-value, so yes, it really does. But does looking at cookie dough, moose tracks, Neapolitan, sherbet, vanilla, all those different things, no, they don't really. Look at all those big p-values. Does cookie dough seem to affect the walking value? In other words, does it change the slope based off your ice cream? Large p-value, large p-value, large p-value. All I see are large p-values. So I'm going to go back to my model. Letting the ice cream change the slope doesn't seem to matter. If I take that part out, then I still don't see any effect of ice cream. This is going to change the intercept. That one's the closest, but it's still not less than 0.05. It doesn't look like ice cream helps me at all. So I'm going to take it out of my model, and here I just have a simple model with walking. In other words, here's an example of where the ice cream wasn't helpful to the predictions. You want to predict how old someone is? You can't look at their favorite flavor of ice cream to be able to tell. That's just not how it works. Let's try a different data set. This is the liver data set. We have how much enzymes they have in their liver, their alcohol use, and we're giving them a specific drug. Some people get a placebo, other people get various other drugs. Try to see if it affects the enzyme level. If I try to read in the data, I'm going to get an error. Why? Because my original data set had these explanations in words at the top. So I need to skip 2 lines before the data begins. And this skip command is something we've seen before. There I read in the data. Once again, I want to take a look at a picture. And I'm asking myself, do the blue dots follow a different pattern than the green dots? Well, I don't know. This is pretty hard to see, but I can ask R to look into it for me. Once I've made a fit, I'm of course checking my residual plots. And you'll notice there's streaking here. That's because the original data set had specific values for enzymes, 50, 51, 52. And so that's why we're seeing these kinds of discrete values in here. You can't have 50.5, which would have caused the dots to go here in the middle. So the streaking isn't a problem. That's part of the nature of the data. But do we see any overall patterns? Not so much. I think it's okay. No data points that are really weird. And I'm trying to go fast in just an overall view here. But what do we see in the overall fit? Does alcohol level affect the enzymes of your liver? Absolutely yes. Do these different drugs also affect it? Well, not so much, except here, this paraplenone B, and this is compared to the placebo, because I purposely called it AB placebo so that it would be the baseline. We'll talk about how that works later. Does the different drug affect the slope? In other words, does the alcohol interact with the drug to change the enzyme level? And for this pathomoic drug, no, not so much. But the other 2 drugs, yes, there is a change. So I could draw these lines if I wanted on top of this original graph to help you see what I'm talking about. So I make my X hat and I make a different Y hat for each of the 4 different categories. And where these numbers come from, don't worry about it right now. Just know that that means I can plot these lines on here. I even put a legend so I can talk about it. So what do we see with the placebo? There's a huge effect of how more alcohol increases the number of enzymes. Here with the piamoic, we see that it's pretty close, not that different. And here in our summary output, it also shows not that different. So the black and green lines, pretty much similar, but the red and blue lines, these two different medicines, mycin, I don't know how it's pronounced, imperial planolin B, these are very different. They change how having more alcohol does not increase the enzyme level quite as much. If that's confusing, it's okay. I just want you to have kind of a general idea of what it's like to do an analysis with this stuff. And in the next few videos, we'll go over details, hopefully clear up some of that confusion.